This is another type of multiple body problem called an Atwoods machine. There's a picture of an Atwoods machine right there. It's a pulley and it's got two masses, one bigger than the other on each side. And the two assumptions that we're going to make for now, anyway, when we're solving Atwoods machines problems are that the rope slides without friction on the wheel and that the tension is equal all throughout the rope. We're going to change these assumptions in the future, but for now we're going to start relatively simply and we're going to assume that the rope slides without friction on the wheel and the tension is equal throughout. Now, what point one means, the rope slides without friction on the wheel? What that means is that the pulley doesn't rotate. That's what that means. The rope just slides, so that wheel is not turning. Now, when we solve an Atwoods machine problem, we're going to model the system to look slightly differently. We're going to take this two-mass system that's connected by a rope, and you see how mentally I've brought it out here like this. And in reality, we know that there's an m small times g that's pulling down on this side, and on this side there's an m big. I won't write the word big, I'll just put b and s for small. There's a weight of this mass times gravity. There's a weight of this mass times gravity. So what we're going to do is I'm just going to stretch that out and I'm going to say, okay, that's pulling in that direction and that's pulling in that direction. We're taking the real system and we're simplifying it. We're modeling it in this way, and you'll see why here in just a second, because now we can say, you know what? Let's write out Newton's second law here, that the net force is equal to the mass times the acceleration. The net force on this system is just this bigger mg, mb times g, minus the smaller one. The net force on the system is the mass of the bigger one times g minus the mass of the smaller one times g, and that needs to equal the total mass of the system, which is mb plus ms times the acceleration of the system. We could factor out g over here. Why don't we factor it out now? If we solve this for the acceleration, what kind of an expression will we get? We'll get the acceleration is equal to g multiplied by the quantity mb minus ms over mb plus ms. The tension, we talked about internal forces a couple videos ago. If this is the system, the tension in the rope is an internal force. What's the tension? Well, we can't find it if that's the system. To find the tension, what we need to do is we need to consider either just the small mass or the big mass as the system. And it doesn't matter which. Let's say that the system is the big mass. You see, we can change the system to be whatever we want. As long as we are consistent in everything we're doing, we're going to be fine. So if the system is the big mass, what would a free body diagram of it look like? There's the big mass right there. And doesn't it have M, B, G pulling to the right? And then there's a tension pulling back to the left. I'm going to draw that tension vector shorter than MBG because we know that this mass here, this big mass, is accelerating in a particular direction. You can tell by the original picture. You look up there at the original picture. Isn't it clear that MBG has to be bigger than tension? You see, if tension were bigger, MB would be accelerating up, and that's not the case. Let's use Newton's second law. What's Newton's second law? The sum of the forces, MBG minus the tension equals the mass, which is MB, times the acceleration. Okay, wait, there's the acceleration. So let me substitute that in. Put G there, mb minus ms. In the denominator, put mb plus ms. So if we solve this for the tension, that goes over there, that goes over there. Again, we could factor out some things, but I don't want to waste your time here. But you see if this seems to make sense. MBG, and then we end up subtracting this whole thing. MBG, MB minus MS over MB plus MS. There you go. Again, we could factor out an MBG if we wanted and put the quantity 1 minus something. That would be perfectly good. Should we do that real quick, just so that we can make it look a little bit prettier? If we factor out MBG, don't we get 1 minus the quantity MB minus MS over MB plus MS, something like that. It's a little bit prettier than what we had boxed in previously, but they're equivalent.